SAR Averøy is a treatment plant for oil drilling waste with the best technology available. Its estimated capacity is 50,000 tons slop and 35,000 tons of drill cuttings per year. Fluids are pumped directly from tankers or vessels to receiving tanks. The receiving tank receives crude slop from tankers or supply vessels. The process tank, feed tank for the WOSS process. The process water tank contains water generated from the WOSS process and is a storage tank for water treatment. The concentrate tank, concentrate or condensed account from the filtering process. A fluid is used to moderate dust in the TCC process. Slop from the process tank is mixed with a surfactant and pumped to a shaker which separates out larger objects and particles so that they don't reach the treatment plant. At this stage, the fluid is heated in the pre-treatment tanks before being pumped into the decanters. The purpose of decantation is to separate the dry substance or residue from the fluid phase. The residue from decanters will later be treated in the plant for treatment of drilling cuttings. The fluid phase from decantation will be further separated in a high-speed disc centrifuge. This process separates oil, water, and smaller particles. At this stage, the oil is so pure that it can be used as fuel. The water has to go through different treatment steps to achieve the desired or requested quality. The first step is ultrafiltration to remove oil and particles. Then, the water goes through nanofilters and is finally given biological treatment before being discharged into the sea. The method of treatment is, in principle, a blend of the right doses of chemicals, heat treatment, mechanical separation by decantation, centrifuges, filtering, and finally, biological treatment. SAR has devoted a great deal of its time to improve and develop a unique treatment method to split oil-based slop. The different fluid companies have probably used a great deal of money to tailor-made drilling fluids with strong emulsions to withstand both high pressures and temperatures downhole. Our unique method is designed such that over 99% of the precious oil can be recovered and used as energy source elsewhere or for other purposes. The purpose of a TCC unit is to convert hazardous, oily waste into useful products. Typical drilling waste contains 70% mineral solids, 15% water, and 15% oil. This rather sticky mess is loaded into a feed hopper. Below the hopper, a double piston pump efficiently transports the waste into the next process step. The process consists of some main process steps: a feeding system, a heating process, equipment for further cleansing of oil vapors from the mill, and condensing systems for oil and water. All functions in the process are controlled by an advanced PLS system, which makes the manpower requirements comparably low. The key component in the TCC is the process mill. In the TCC, kinetic energy is transformed into heat through friction created in the waste itself. This is the main difference between a TCC and other thermal technologies based on indirect heating. And the core benefits of the TCC are all related to this difference. A diesel or electric drive unit, typically with an effective output of 700 kilowatts, sets a series of shaft-mounted hammer arms in motion inside a barrel-shaped vessel. Before processing starts, there are only dried solids in the vessel. The motor drives the hammer shaft, forcing the solid particles towards the inner wall of the stator, where the kinetic energy from the rotating arms will be transferred into heat by friction. When the unit has reached a preset temperature, waste is automatically fed into the reaction chamber, where it's heated by the solids already present. The solids in the waste and in the chamber are thus combined, and the oil and water evaporate instantly. The solids are discharged from the chamber through an efficient, automated ThermTech discharge valve which prevents oil leaking out or oxygen leaking in. A residual amount of solids will be carried by the vapors out of the process mill. and for that reason, the vapor stream passes through a cyclone where most of them are taken out. To secure maximum quality of the oil, the vapors will also pass through an oil scrubber, where the remainder of the solid particles are separated from the vapor stream. The next step is an oil condenser, where the oil vapors are recondensed into high-quality liquid oil. Afterwards, the water vapor is also recondensed back into liquid. Trace amounts of oil will be present in the water and are subsequently removed using a traditional oil-water separator. The solid is passing through a transport screw which cools them to an acceptable temperature. Depending on how they're to be used next, they are then placed in dry or wet storage, the latter to prevent the buildup of dust.